Hello everyone. In this lecture, I shall discuss the Newton's backward interpolations. Okay. So now if you recall the Newton forward interpolation here, we have the forward operator is delta and the backward operator is inverted delta, or sometimes we call it nabla. So now in your forward operator, del fxi means next minus that. Okay. So here f0 means del f0 means next f1 minus f0. Then likewise in your backward it is same thing minus the previous. If I ask you what is this is your backward. Okay, this is your backward. If I ask you what is of del of f1 fx1 means it is your fx1 minus this previous fx0. Okay. So similarly, if I ask you what is your del f2, it will be this f2 same minus the previous f1. Okay. If I ask you what is del f3, it is the f3 minus this previous means f2. If I likewise ask you what is your del square f2, suppose I ask, then it will be your del f2. Now del f2 value I substitute del of it is f3 minus f2. Okay, so this is del f3 minus del f2. Sorry, it is del f2 means it is del f2 means same thing, f2 minus f1, and it will be del f2 minus del f1. Okay, so now what is del f2? Del f2 is same thing, here f2 minus f1, and my del f1 means it is my again f1 minus previous. So this is here f2 minus 2f1 plus f0. So now if you compare this with this, you see here this del square f0 is the same thing as del square f2. So del square f2 here is here del forward f0, is not it? And similarly here del f1, right? Del f1, this del f1 is f1 minus f0, right? It is f1 minus f0. So del f1 is here del f0. So del f, this is nothing but here del f1, right? And this is here del f2. Okay, so in that way we can compare. So these details of operator and their comparison, we will discuss it in another lecture, the finite difference operators and their relation. Now in view of your forward interpolation, we will now develop the formula for your backward interpolation. Prior to that, let me to introduce myself. Professor Kumar Paikray, currently working as a professor in the Department of Mathematics, Veer, Surendra, University of Technology, Burla, Odisha, India. So without much delay, let us now proceed to write the formula for Newton backward interpolation. Now let us derive the formula for Newton backward interpolation formula. Also it is called Gregory-Newton or Newton-Gregory backward interpolation, because this backward operator was initiated by James Gregory. So combined with the interpolation of Newton, we call it Gregory-Newton. So if I recall here the Newton forward interpolation formula, right, in both the cases a table is given, and accordingly the tabulated data is given. Here the thing is that this gap is equal gap here. Now if it is close to the initial point, then we use forward. Now in backward, what will happen? It is close to the final point. So the necessary formula here will be, here px will be here f0 is taken in forward, here fn will be taken in backward. It is fn, f of xn plus x minus xn. Okay, here x0 is replaced by xn. It is del fn by h. Okay, the next will be x minus xn into x minus xn minus 1. Come to this point, into it is here del square fn, inverted del here, divided by h square factorial 2. If you go on continue like this, it will be x minus xn minus 1. It will come up to the last minus 1. So it will come up to this. Okay, it will come up to this. In previous case it has come up to this, right? So here it will come up to this. So it will be up to x minus x1. It is del n fn, means fxn, by h to the power n into factorial n. So this is the necessary formula. And likewise we can generate a simplified formula. Here for the simplified formula, what we did, we put x minus x0 is equal to uh. Accordingly this formula was f0 plus u del f0 plus u into u minus 1 del square f0 by factorial 2, so on. Here u minus 1 up to u minus of n minus 1. Okay, it is del n f0 by factorial n, in that way. So accordingly here we will take put x minus xn is equal to uh, right, or this implies here x minus xn by h is equal to u. Accordingly we will compute the other points. So accordingly this is here x minus xn, then I need x minus xn minus 1. So what is x minus xn minus 1? It is x minus just 1 less to h less to xn. So this is here x minus xn minus plus h. This is here uh. So this is uh plus h. So this is equal to u plus 1 into h. Okay, then accordingly you continue. Accordingly your x minus x1 will be x minus xn minus here n minus 1 times h. Okay, so this is here x minus xn plus n minus 1 h. So this is x minus xn is here uh plus n minus 1 h. So this is h taken common, u plus n minus 1 into h. So therefore if you substitute here, then what will be your px? Therefore here px will be, therefore your px will be necessary formula for Newton backward interpolation formula will be px will be here f of xn plus u inverted del fxn, okay, plus u into u plus 1. It is del square fxn. This is by factorial 2. Okay, and if you go on continue like this, it is u plus 1, then u plus 2, it will come up to u plus n minus 1. It is del n fn by factorial n. So this is the necessary formula for your Newton backward interpolation, where u is your x minus xn divided by h, and we use this formula if it is asked to find the interpolating polynomial close to your xn, maybe little left to xn, maybe little right to xn. However, in any case we can use forward or backward. So to minimize the error, to have a better estimation, we choose the point close to the final point, and for your forward we choose it close to the initial point. Okay, so for Newton forward we use this, and for Newton backward we use this. Okay, so now let us solve some problems so that your idea will clear. So now coming to this example, following table gives the values of tan x in the interval 0.1 to 0.3. You are asked to find tan of 0.26. So this is the table given. We see here these are all equispaced. Okay, these are all equispaced. What is here h? Here h is 0.05, is not it? This gap is 0.05. Now it is asked to find fx is my tan x. Fx is my tan x. Now you are asked to find a value 0.26. 0.26 is here. This 0.26 is here, which is close to the end. Okay, so we use Newton backward. So this is a equispaced. The given table, the given data is equispaced, and we have to find the polynomial at x is equal to 0.26, which is close to xn. Thus we use Newton backward interpolation formula. So before that we should first compute the backward difference table. We have to compute. So I write x and the value of fx. This is my fx now. So I write the value of x and fx. Okay. Now coming to the table. In this table, it is my del of f here. So now you see, here it is del f1 is f1 minus the previous. Okay. The calculation is same, but in the previous case we write it f0, forward f0. So now this calculation is same, and it is my del f2 only. So this is this f2 minus f1. The calculation is same, f2 minus f1, and this minus this, it is your inverted del f3. It is my f3 minus f2, and it is my inverted del f4. I read it del, so it is 4 minus 3. The computation is same. The forward computation, if we do not write it del or del, if I write first order, second order, then this computation is same, right? Then accordingly my second order I will calculate. So let me to find this difference. So here this difference value will be, if I subtract it, it will be my 0.0508. It will be my 0.0516. It will be my 0.0526. It will be my 0.0540. So now coming to my second order. In my second order, right? Then irrespective of whether I write del or del, then the same table will work, and I just find this difference. So this difference here is 0.0008, and this difference here is, it is my 0.0010, and this difference here is, it is my 0.0014. Okay, then I find actually this will my del square f2, is not it? It will be my simply del square f2. So next I have my third order and I have my fourth order. In my third order I find this minus this, so this will be 0.0002, and this will be 0.0004, and the fourth order I find this gap 0.0002. Actually you see, this is here del fn, is not it? It is here del square fn. It is here del square fn, is not it? It is here del q fn. It is here del square inverted del, sorry. It is here del f. It is here del fourth f4. Okay. So now we use this only for your backward computation. We use, it is my x4. It is my xn. X4 is my xn here. So actually in backward I use this only. This thing will be computed. Now irrespective of whether it is a forward table or backward table, if it is asked a forward table, right, in the same thing, suppose you are asked to compute forward and backward both, then this will be x0, this will be my f0, this will be my del f0, this will be my del f0, this will be my del square f0, this will be my del q f0, this will be my del fourth f0. Means in the same table itself I can use the forward or backward, right? And I write it simply first order. Okay, then I may use this. So this to same problem I can use the forward formula or the backward formula, no issue. But if I use the backward formula, then the estimate is very close to the final answer, the error is less. Okay, so let me to use the formula now. Clearly, before I use the formula, my xn is equal to x4 is my 0.30, and my fn is f4 is my 0.3093, and my del fn, as I know del fn I got it 0.0540, and I have my del square fn is I got it 0.0014, and my del q fn I get it 0.0004 and my del 4th fn I get it 0.0002. So these are the information. And what is my u now? My u is x minus xn by h. So x is given 0.26 minus xn is 0.30 and h as I have told it is 0.05. If I simplify it, it is minus 0.8. Now I am ready to use the formula. So what is my necessary formula? Newton backward interpolation formula. So it is so it is your p of x is equal to your fn plus del fn plus, just 1 second, it is x minus xn into, it is your u into del fn plus u into u plus 1 into del square fn by factorial 2 plus u into u plus 1 into u plus 2 into del q fn by factorial 3 plus dot dot dot. I just write it. So now I substitute all this thing here. So if I simplify it, I will get, so the fn value, it is my 0.3043. I substitute all this thing. So if I substitute all this data, then I get it my p of 0.26. This is nothing but my tan of 0.26 in radian mode. Okay, and after the computation it will be 0.26602. So this is my answer. If at all I want to alternatively, if I want to apply the forward, if I want to apply the Newton forward interpolation formula, I can solve it. I can also solve it. It is px is equal to f0 plus u del f0 plus u into u minus 1 del square f0 by factorial 2 plus so on, and I can solve it. The value of f0, the value of f0 del f0, I can solve it. So your value of f0 is 0.1003 plus u, accordingly I have to compute here. Here u will be x minus x0 by h. So x is 0.26 minus here x0 is here 0.1 divided by 0.05. So accordingly this is my u. So I can apply the formula u del f0, u into u minus 1 del square f0, and accordingly if I simplify, I get answer. Now this answer may be close to this, but this is very close to the real answer, very close to exact answer, exact root. Okay, so here error is a little more. So accordingly we choose the best formula depending upon whether it is close to the initial point or it is close to the terminal point. Okay, now let us solve some more examples. Now coming to the solution. So here we are asked to find the area when the diameter is 105 unit. Okay, so 105 is here, it is close to the end point. So we use Newton backward. Okay, so we write the difference table without mentioning whether it is forward or backward, because the same table can be used for both the formula. Okay, so now the first order difference means here we just need to find this difference only. So this difference is my 648 and this difference here is my 688. This difference here is my 726 and this difference here is my 766. And I find this difference again, and it is here 40 and it is my 38, it is my 40, and this difference here is minus 2 and here it is here 2 and this difference is 4. So since we are using the backward interpolation, I am going to use this thing only, because it is my del fn, it is my del square fn, it is my del q fn, it is my del 4th fn. If at all I ask to use the forward, I can use this only. Okay, this will be my del f0, this is my del square f0, this is my del q f0, this is my del 4th f0. Means from this is my f0 and this is my fn. So means from the same table we can use the forward formula as well as we can use the backward formula. What is h here? The gap here is 5, so h is here 5. Okay, so now here my xn is equal to 100, xn is equal to 100, h is equal to 5, and accordingly I find u is equal to x minus x0 by h. So this is x is given here is 105, x is 105 is asked, means f of 105 is asked to you. So 105 minus 80 divided by here 5. So this is 25 by 5 is 5. Now you have your formula, Newton backward interpolation formula. So it is here P of 105 is equal to, I can directly write P of 105 is equal to Fn plus U Fn, U del Fn plus U into U plus 1 del square Fn by 2 factorial, and so on you continue, and you finally substitute all this thing here. So it will be here f of Fn is here 7854, it is 7854 plus U, what is your U here? So U is here 5, sorry there is a correction. So U is here x minus xn by h, xn is 100, so this is 100, so this is 5 by 5 is 1. Okay, so here U is 1 here. So if you calculate, it is 1 into Fn is my 766, then it will be 1 into 2, and here del square Fn is 40 by 2, then plus 1 into 2 into 3, del Qfn is here 2, 2 by 3 factorial means 6, then plus 1 into 2 into 3 into 4, del 4th Fn is my 4, it is 4 into 4 by here factorial 4, 24. So if I simplify it, it is 7854 plus 766 plus 40 plus 2 plus 4, so this is equal to 8666. So the corresponding area is, therefore the corresponding area is 8666 square units, you may write, or not square units. Okay, so this is your answer. Let us solve one more problem. Now coming to the solution, so you are given this data. So if you find the difference table here, you are asked to find, it is x0 is 40 and xn is here 90, you are asked to find f of 38, it is close to x0, you use Newton forward interpolation here, and it is close to xn, so you use Newton backward interpolation here. So from the same table you apply both the formula. Okay, so we consider the difference table, right? So I write x and my f of x, the x is given here is 40, 50, 60 up to 90, it is 40, 50, 60, 70, 80 and 90, and the corresponding f I write, it is 184, 204, 184, 204, 226, 250, 276, 304. I just find the first order difference. First difference means I find this gap only. Okay, so this gap only, and this will my 20, this is 22, this is 24, I write at the middle, and here this is my 26, this is my 28. And what is my second difference? I find this gap is my 2, this gap is my 2, this gap is my 2, this is 2. Again my third difference here is, this gap is 0, this 0 and this 0, and my fourth difference is also 0 and 0, and my fifth difference is also my 0. Okay, so now for the Newton forward I use it. I use this. So this is my f0, this is my x0, this is del f0, del square f0, del q f0, del 4th f0 and del 5 f0. I use it. Now for backward I should use it. For it is my fn it is my it is my xn, it is del fn, it is del square fn, it is del q fn, it is del fourth fn. Sorry, this is del fn, this is del square, this is del q, this is del fourth fn, this is del 5 fn, and it is my simply fn. Okay, so now I can use it, the different formula I will use it here as follows. Find f of 38. Okay, to find f of 38 we will use here Newton forward interpolation formula. Okay, so what is my, in all the cases this h is 10 here. Okay, and here my x0 is 40 here. So what is u? U is equal to x minus x0 divided by h. X is my 38. Okay, this is my x. So this is my 38 minus 40 divided by 10. So this is my minus 0.2. This is my minus of 0.2. Minus of 0.2. Now I am ready to apply the Newton forward interpolation formula. The forward interpolation formula is given by here p of x is equal to f0 plus u del f0 plus u into u minus 1 del square f0 by factorial 2 plus u into u minus 1 into u minus 2 del q f0 by factorial 3 plus so on. So here it will del q onwards as 0 here. Now I just substitute these values. My f0 value is 184 plus my u is my minus 0.2 into my del f0 is 20. Then plus it is minus 0.2 minus 0.2 minus 1 into minus 0.3 divided by your factorial 2 here into del square f0 here is my 2, and rest onwards is my 0. Okay, so 0 plus 0 plus 0, no need to write, and I just simplified. After simplifications it will give me 180.24. So therefore my f of 38 is 180.24. Now for this f of 85 we have to use the backward difference. Now to find f of 85, now from the table you see I write xn del fn so on. So my xn here is 90, my fn is 304, my del fn is 28, my del square fn is 2, and my del q fn, del fourth fn, and my del 5 fn, because these are all 0, is equal to 0. So now what is my u? U is equal to x minus xn by h. H is my 10. H is my 10. So my u is equal to x is 85 minus 90 divided by 10. So it is my minus of 0.5. Now the necessary formula. The necessary formula for Newton backward interpolation is here p of x is equal to fn plus x minus xn del fn plus, so actually this is u del fn plus it is u into u plus 1 del square fn by factorial 2 and so on. Now just I substitute this formula here. Okay, so this is my 90, f of xn is 304, so this is my 304 plus minus of 0.5 into 28 plus minus of 0.5 into minus of 0.5 plus 1 is minus 0.6 into 2 by factorial 2, and onwards it is 0 plus 0 plus 0, right? So just I simplify it. It will give me 289.75. So therefore my f of 85 is 289.75. Now coming to the conclusion of this lecture. So for your equispaced data you may use the Newton forward and backward. If it is close to your initial point you use forward, if it is close to final point then you use your backward. So now in the last example we have seen, in the same table we use both the formula. Okay, we use both the formula. So carefully you should select the which formula will be chosen for better accuracy. However, both the formula can be used for a particular problem, okay, at a particular value of x. In my upcoming lecture, I shall discuss the difference operators, okay, finite difference operators, and their relationship, okay, and relationship. So now at this juncture, my appeal to all of you that if you find this lecture is useful and interesting, please like and subscribe to this channel, which will boost my motivation to upload the subsequent lecture for your benefit. So thank you all. Have a nice day. Now let us close this lecture here.